Hey folks, this is Coloring Chemist. My name is Connie and welcome back to my channel. I wanted to put out a video that at first glance seems like it's not going to have a lot to do with art, but it will. So this, of course, is the periodic table of the elements. I printed this off from the NIST, which is the National Institute of Standards and Technology, U.S. Department of Commerce. You can get printable periodic tables, gosh, all over the internet. This is like an old friend. Not necessarily this copy, but just the periodic table in general is like an old friend to me. I know I've mentioned numerous times, I am a chemistry teacher. And I've looked at this so much. I've used this so much. It's an old friend. I want to start a series of videos talking about pigments and some history of pigments, what they're made of, the relationships between different pigments, and why sometimes when you look at one color and you look at another color, you think, gosh, they act similarly or they look similar. Why would that be? So I want to look at those kinds of things. But before we do that, I just wanted to do a quick little. It might be a refresher, it might be new to you, depending on how much chemistry you've taken before, on some of the elements that you'll find in the pigments, and in particular, the chemical symbols for those elements. And what I mean by chemical symbols is this. Now I'm just going to zoom in a bit here. So the chemical symbols on the periodic table are the stuff here that's in, they're usually two letters. Sometimes they're just one, sometimes they're three, often two. The first letter is a capital letter, and the second letter, if there is a second letter, is a lowercase letter. Normally, when chemists talk about elements or, chemical formulas of things, we will use these symbols instead of the names of the elements. And I joke to my students all the time, it's because chemists are lazy. I don't think chemists are lazy. But the symbols are they're a very efficient short form of representing what can sometimes be very long names. So I want to start kind of at the top left-hand corner here of the periodic table and just really when give you an overview. And sorry about the shadow there. I'm trying to do this with natural lighting today. I don't know how well this is working, but when I printed this off, it's got a bit of a gloss on it, and when I turn my filming light on, there's just a reflection. So yeah, just wanted to talk about the elements that we might come across and just sort of give you a base to build on in your mind of, when I say, for example, H, when we're looking at a pigment or the chemical formula for a pigment and you see the letter H, that's hydrogen. Now, a lot of these they make sense. Often it's the first letter of the name of the element, right? H, hydrogen. The trouble is, well, it's not trouble, but if you have, say, more than one element that starts with that letter, then what do, right? H is hydrogen, so if I go over to the other side of the periodic table here, now we don't often find helium in our pigments, but helium obviously also starts with H. So chemists couldn't have, if hydrogen was H, helium couldn't be H. So what you'll sometimes then get is the first and second letter of the name. So helium is He. If we go back, and what I've done here is I've circled on this periodic table the different elements that we might find in some of the pigments we're going to be talking about. Taking a look here, we've got Li, lithium. That one makes sense. So we might find some lithium in some of the pigments we look at. My instinct is to go left to right on the periodic table because that's how you would read the periodic table. But I think what I'm going to do is I'm going to sort of deal with it in sections here, just because I think, particularly for this first bit, sliding the periodic table back and forth left to right is maybe going to make people feel a little nauseous, and I don't want to do that. So instead of going lithium and then all the way over to the other side, I'm just going to go down here. Now, here's another element that we might find in some of our pigments. Sodium. I apologize, this video is probably going to be maybe longer and more in depth than you would want. But I do love chemistry and I love explaining things, and I just love some of the history of some of these elements, and also clearing up some misunderstandings or misconceptions that people might have. When I say the word sodium, what do you think of? Most people tend to think of salt. And salt meaning the stuff that's on your table in a little shaker that you put on your food to make it taste better. That's partially true. And I think the misunderstanding comes because, medical professionals talk about the sodium levels in our diet. But sodium on the periodic table, believe it or not, they don't mean salt. Salt, table salt, like the stuff you put on your food, is something called sodium chloride. It's not just an element, it's something we call a compound. And a compound is just something that's made up of different elements. That's what a compound is. The sodium that's here on the periodic table is a metal, believe it or not. And not only that, it's a metal that if you put it in water, bursts into flames. I'm not making that up. It really does. So, yeah, that's an element we might find in some of our pigments. Curious thing here, remember we were talking about those symbols and the names? Sodium, you would think, would have a chemical formula of SO, right? Those would be the first two letters. But it doesn't. It has a chemical symbol of Na. Now, why would that be? Well, we're going to see on the periodic table, and potassium is another one. Potassium, you would think, would have the chemical symbol of P, but it doesn't. It has the chemical symbol of K. And the reason for that is because some of these chemical symbols are based on the Latin names for the elements. Sodium, for example, in Latin is natrium. Potassium in Latin is kalium. So some of these older elements, these elements that were known sort of, long before Western science got a hold of things, the chemical symbols for those elements are based on old Latin names. So if we're seeing, Na in some of the chemical formulas for our pigments, we just need to remember Na is sodium. That's weird, but it is. K is potassium. Also weird, but it is. Magnesium, you'd think would be Ma, but it's not. It's Mg. So they don't always take the first two letters, but in this case they took the first and third. That kind of makes sense. Calcium, they did take the first two letters, Ca. Titanium, of course, we see a lot in our pigments, right? Titanium white. Titanium is Ti. And I will say, before we get too far, when we see a pigment titanium white, and then we're seeing it here on the periodic table, you might be, thinking, well, titanium white is just pure titanium. It's not. Titanium itself is a metal. Titanium white is something else. And when we start to look at pigments in more detail, we'll talk about what that something else is. This is just, like I say, just a little primer for the periodic table. Vanadium, that's another element we might see in our pigments that just has a symbol of V. Chromium is Cr, which isn't the first two letters, but because chromium is Chr, but it still makes sense. Remember, magnesium was Mg. Manganese, which sounds similar but is different, is Mn. Here's another weird one. Iron. Iron is Fe. That's weird, isn't it? The Latin for iron is ferrum. Ferrum. That's why iron, the chemical symbol for iron, is Fe, ferrum. Cobalt, Co, that makes sense. Nickel is another element that we'll see in our pigments. Ni, that also makes sense. I'm going to shift over here. Copper sort of makes sense. There's a C, but copper, of course, is spelled C-O-P-P-E-R in English. But the chemical symbol for copper is Cu. Where did the U come from? Odd. Copper in Latin is C-U-P-R-U-M. Oh, that U looked like an O. Oops. Cuprum. So C-U-P-R-U-M, cuprum, that's why copper is C-U. Zinc, Z-Z-Z-Z-N. We say Z in Canada. That would make sense. Just kind of pop back up here. Aluminum, Al, that one makes sense. Silicon, not silicone. Silicone, as in sort of breast implants, that's different. This is silicon. So silicon, Si, that one kind of makes sense. Or it does make sense. Phosphorus, P, makes sense. Sulfur, S, makes sense. Chlorine, we'll see all these in our pigment formulas. Cl, that one makes sense. The three up here, carbon, C, just a plain old C, that one makes sense. Nitrogen, N, oxygen, O, those ones all make sense. Arsenic, As, believe it or not, we will see that in our pigments. Arsenic makes a very lovely green pigment, which is very deadly. Has to do with wallpaper. We'll talk about that later. But As, kind of makes sense. It's not Ar. Ar, of course, is up here. So if argon was Ar, arsenic couldn't be Ar, so it's As. Selenium, that's another one we're going to see. Se makes sense. Bromine, Br. Now, I should comment, you'll see the different colors of squares here. Those aren't the colors of the elements. You'll notice a little kind of legend here. Any of these elements that occur at room temperature as solids have white squares. Any of them that occur as liquids at room temperature have purple squares. Any of them that are gases at room temperature have red squares. And any of them that are artificially prepared, in other words, they don't exist outside a laboratory, those are in kind of a blue-gray square or blue-green square. So the fact that all these are pinky red squares here, right, that just means they're gases at room temperature. Bromine is actually a liquid, room temperature, and then all these white ones are solids, which makes sense. I mean, copper at room temperature, and when I say room temperature, I mean, your typical, in Canada, we would say 20, 22 degrees Celsius, kind of a 70-ish room temperature Fahrenheit. It makes sense that, things like nickel and copper and zinc, those are solids at room temperature. So, just a few more to look at here. I'm going to slide over. Try and make it straight. Barium, Ba, that's another one that we'll see in some of our formulas. Zirconium, yes, cubic zirconia. This is a diamond, but the same kind of idea would have something to do with that element. But zirconium itself is a metal. Zr makes sense. Molybdenum, that's just fun to say. Molybdenum. Mo, that would make sense. One lone one way down here. Cerium, Ce, again makes sense. Slide this over. Just a few more down here. Now there's quite a few in this little area here that have some really interesting kind of backstory as to why their chemical symbols are what they are. Cadmium, of course, we see that all the time. And we talked about that in that previous video that I had where I talked about how to pronounce those sort of crazy pigment names. Not that cadmium is that crazy, but it was on there. It can't be Ca because calcium was Ca. So this is Cd. Mercury. Yeah, there's going to be mercury in some of the pigments. Now, when I talk about the pigments, I'm actually going to start way back in history. So I'm going to talk about some pigments that probably lots of them maybe aren't used anymore. Like I was saying, that arsenic pigment that makes a lovely green that's very toxic. That particular pigment is no longer made or sold because it's very toxic. So sometimes some of the pigments we're going to talk about are going to use things, like mercury, which in certain forms, not all forms, but certain forms can be toxic. Those kinds of things may not, those pigments may not be in use anymore. Mercury is Hg. That seems to make no sense whatsoever. But that's because mercury, and I don't want to write on my, kind of go down in here. Mercury is in Latin. Oh, and I always miss, this is hard to say. It's hydrargium. Hydrargium. Actually, I'm not even sure that second is. No, I think it is in there. Hydrargium. Future editing Connie here. I knew I had misspelled that, and I couldn't think of why. It's actually hydrargyrum. And so there was a Y in there that I had forgotten. So I do apologize for that, but there's the correct spelling of it. But that's why it's Hg. A little square here. The only one out of this little square that does seem to make sense is bismuth. And we did talk about that one in that previous video as well. And I'll link that previous video down below. Bi, bismuth, that makes sense. These other three seem to make no sense. Looking at Sn, would you ever guess that was tin? It is. And that's because tin in Latin, and I'm going to, how can I do this? I'll go over here. Tin in Latin is, better make sure I'm on screen. Stannum. So that's why tin is Sn. Antimony is another element that we're going to see. It's Sb. There's not an S or a B in the word antimony. And so why is it that? Because antimony in Latin is stibium. That's why it's Sb. And the last one that we'll look at, the last element, which I think, I don't know, there's just so much cool stuff on here. I could go on forever, but I won't. Lead. Lead is Pb. There's not a P or a B in the word lead. So why is lead Pb? Because Latin for lead is, and I teach high school, I've also taught college chemistry, and some of the younger high school students, of course, the minute I say this, they giggle. Because Latin for lead is plumbum. Of course, the word bum makes students giggle. But that was Latin for lead. It's plumbum. Interestingly, what word or what occupation in English can you think of that word might remind you of? Plumber, perhaps? And so what does a plumber do? A plumber works with pipes that carry water and waste to and from your home, right? The Romans, who were the ones that had the, Latin language, the Romans were one of the first civilizations to have a system of pipes to carry water and waste to and from their homes. Now, back then, of course, they didn't have, modern plastics and all the, other kinds of stuff. So what they needed was a kind of material that was cheap, number one. There was lots of, relatively easy to get and work with, and that was relatively bendable and flexible. I mean, think about the plumbing in your home, right? It's not just one straight line. So you couldn't have something that was too strong or that you couldn't bend. Lead fit those bills. If anyone has ever, had a piece of lead in their hand, it's very soft. You can bend it with your hands. It's cheap, and they had a lot of it. So the very first pipes that brought water or, to homes and took waste away were made of lead. And it was in ancient Rome. They spoke Latin. And so the folks that worked on those pipes or put those pipes in place were called plumbers because they worked with lead, plumbum. The system that carried the water that was made of these lead pipes was called plumbing. Isn't that fascinating? I love that kind of stuff. A plumb line. You might have heard that, in terms of building, right? A plumb line has a lead weight tied to the end of a string, and if you dangle it down, it will dangle down it dangles straight down. And so you can use a plumb line to figure out if something is straight up and down or not without, any kind of measuring or not, because gravity says that it will it will hang straight down. A plumb line is called that because normally the weight on the end of that line is made of lead, and Latin for lead was plumbum. All right. Well, this is 20 minutes. That's probably more than anyone wanted to spend on. Oh, sorry. Big truck going by. More than anyone wanted to spend learning about the periodic table. But I hope this is, relatively somewhat interesting. And I promise, sort of knowing, and I will obviously do reminders of these things, these different elements and their symbols when we go to do our video series on, just gonna zoom back out there. There we go. When we do our video series on all of the pigments, because I don't expect you guys to memorize this. So, yeah. Hope everyone is well. Hope everyone is safe. And I hope everyone is enjoying their coloring. Until next time, goodbye.